Hello everybody, today we are going to start on Unit 5, Day 3, and this is actually about our last method for solving systems of equations. We are going to be talking about solving systems by elimination. It is also sometimes known as linear combinations. Okay, you'll probably hear me talk about elimination more than anything else, but knowing this kind of helps you give a little bit of a insight of what we need to do in order to use it. So let's go ahead and get started. So elimination is combining the equations, so adding them together, to eliminate a variable, which means cancel them out, and solve for the remaining variable. That's our whole goal when we do elimination. Now, how to eliminate? Step 1 is to arrange the equations in the system so that the like terms line up with each other. So x is on top of x, y on top of y, number on top of number. Okay? That order that they're in doesn't really matter, but if you're going to change, so one's not in the correct order, it doesn't line up, when you change it, you have to use the inverse property to move terms from one side of the equation to the other. So just be aware of that. The second step, we're going to multiply either one or both of the equations so that one of the variables, whichever one you choose, x or y, have opposite coefficients in the equation. So sometimes you might not need to, when you line them up, you might not need to multiply anything because the y's, like one y could be positive 2, the other y could be negative 2, so when you add them together, they cancel each other out. However, that doesn't always happen, so you might have to multiply the entire equation on the top by negative 2 in order to get it so they have the same number but different signs for them to cancel out when you combine them. Okay? Step 3 is to actually combine the equations, so you add the variables together. Again, you add like terms together and then solve for the remaining variable. So when you combine, one of the variables should disappear because it cancels out. It gives you 0. Okay, if you still have two equations at the end, you did not either line them up correctly, you didn't combine them correctly, you didn't multiply it correctly. Something went wrong. So after your addition, you should only have one variable left. Okay? When you only have one variable left, you can go ahead and solve for that like a normal equation. Step 4 then, once you have that value for that variable that you had left, you plug that back in, and you solve for the other variable that you need. Okay, very similar. Step 4 and 5 are the same as for substitution. 5 is check your solution to make sure you have it, and you check it in each equation. So, okay? I know it seems very confusing because we're talking about it without actually seeing an example. So let's try an example now. Okay? So, example. Solve a system of equations by elimination. Alright, so here we have 4x minus y equals 6, and we have y equals 5x minus 9. Now, we need our variables to line up. So this one has x and y on the same side. This one does not. Okay? How you line them up is up to you. Okay, so that you could do something very different than what I do, and it still could give you the correct answer. Alright? My rule of thumb is I basically base it off of the first equation and try to get the second equation to match it. So here we have an x, and then a y, and then a number. So that's what I'm going to do. I'm going to move this x term to the other side, so I'm going to subtract 5x from both sides, and then I'm just going to put it in front of the y so it lines up. So now I have 4x minus y equals 6 on the top. Didn't change anything there. But on the bottom, I have negative 5x plus y equals negative 9. Okay? So this is my system. It's still the same system. All I do is manipulate it. And it works because, look here. The y's have the same number, the 1, that invisible 1, but they have opposite signs. Okay? So these are opposite coefficients. This means when I add them together, the y's will actually cancel out. So I'm going to add these equations together. So 4x plus negative 5x gives me negative x, negative 1x. The y's cancel out, so I'm left with nothing for y. And 6 plus negative 9 gives me negative 3. Okay, now I can just go ahead and solve for x because that's the only variable there. I divide everything by negative 1, and I get x equals 3. That's half of my answer right now. So just like with substitution, I'm going to take this x value and plug it back into one of these equations. I'm actually going to choose the bottom one because it looks easier. That's the only reason why. So I'm going to plug x plug in 3 for x here. So 5 times 3 minus 9. 5 times 3 is 15. 15 minus 9 gives me 6. So the y value is 6. Which means my solution is 3, 6. Okay? And then I can check it by hand by plugging in the x and y into the two original equations. Okay? So, I think the next one's an example. Here's another example. Okay? This one's already lined up. The y's are on top of each other. The x's are next, and then the numbers. The issue here, though, is that the y's are both positive. The x's, one's positive, one's negative, but they are different numbers. So I have to figure out which one to change, like which one to try to get rid of, so that they will be opposite coefficients. Again, the choice is yours. You might say, oh, well, they already have the same number. I just have to multiply 1 to be, so it becomes -1. Or you might say, oh, well, this is already positive and negative. I just need this to be a +3 here. It's up to you which variable you want to get rid of first. It should not affect your answer. Okay? I saw the x, so I decided I wanted to get rid of the x first. So I need to make this into a +3 so they have the same number but different signs. So to change this x into a +3x, I have to multiply this by +3. Now if I want to multiply this by +3, I have to multiply everything else in the equation by +3 as well. Okay? So every other term gets multiplied by +3. So I do that, it becomes 3y equals 3x minus 9. On the bottom it stays the same. Y equals -3x plus 4. Now my x's have the opposite coefficients. I have a +3 and a -3. When I add these together, it'll give me 0. So that's what I'm going to go ahead and do. I'm going to add, and then the x's will cancel out, and I'll be left with y. So 3y plus 1y gives me 4y. -9 plus 4 gives me -5. So now I can go ahead and just get y by itself. I divide everything by 4. I get y equals -5/4. Not a pretty number, but I can work with it. Okay? Now that I know what y is, I'm going to plug it back in, just like I did with substitution. So I'm going to plug it into this top one because it looks smaller. No other reason other than it's a smaller one. So I plug in -5/4 for y equals x minus 3. So now I just solve for x. I'm going to add 3 to both sides. This gives me 7/4, so x equals 7/4. Okay, so my solution is not a pretty one. 7/4, -5/4. And I can always check my answer to make sure I'm right by plugging it back in. It won't be fun to plug it back in. Okay, but you can do it. Alright. This one you guys are going to try on your own. You will have to adjust some things, so give that a try. You will, by adjust I mean multiply something. It's up to you how you want to multiply. You could do one or both of them so that you figure out the number they have in common. But you're going to try that one on your own. Let's go ahead and try this next example. So this is our system. We have 5x minus 3y equals 5, and -6x minus 2y equals -22. So the x's are different signs, but not the same number. The y's are different signs, but not the same number. So neither of these would cancel out if I added them together right now. So I have to manipulate them. Now, unfortunately, I can't multiply 5 by something to create a +6. And I can't multiply 3 by something to create a +2, and vice versa. I can't do anything on the bottom either. Which means I would have to multiply both equations so they both change into a number that's the same. Okay? And that decision, again, is yours. You can change it so that the x's will be the same, or so that the y's will be the same. The ones that are the same will be the ones that cancel out. Okay? I'm going to go ahead and do the y's because in order to change these numbers, like to multiply them, so they're a common number, the next number they have in common is 6. So I could change these both to be a 6, so this would be a -6 and a +6. And that's smaller multiplication, so that's why I went with it. Where over here I'd have to change them so they both be 30, which is bigger numbers. So It's up to you though. I just went with the y. So here, to change this to a positive 6, I have to multiply everything by 2. Change this to a negative 6, I have to multiply everything by a 3. So that's what I'm going to do. Every single terms will get multiplied. So on the top it becomes 10x plus 6y equals 10. On the bottom we get negative 18x minus 6y equals negative 66. So here, the y's have the same number but different signs. So when I combine them and I add it together, they will actually cancel each other out. So that's what I'm going to go ahead and do and add it together. So 10x plus negative 18x gives me negative 8x. Y's will give me 0, and 10 plus negative 66 turns out to be negative 56. So now I'm just going to go ahead and solve for x. I'm going to divide everything by negative 8. So x actually comes out to be positive 7. Now that I have that, the x term, I'm going to plug it back into one of these equations. I'll just choose the top, plug it in, and then simplify. So 5 times 7 gives me 35. Subtract 35 from both sides. Let me scroll down a little bit. So that will cancel out. So it becomes 3y equals negative 30. And then divide everything by 3. You get y equals negative 10. So my solution comes out to be 7, negative 10. And I can check it the same way we've been checking all of our solutions. Okay? The last one is your try on your own. So this one you will have to manipulate. You will probably have to multiply both. Because I want you guys to practice it. How you multiply it is up to you. Okay? And we can talk about the differences next class. And if you have any questions, write them down. I'll be happy to answer them next class. Other than that, I'll see you guys next time. Bye.